Anyone? Anyone? You want to start with this or the other review? The review for the quiz? Okay. Let's start with this one. All right. So it says state the domain of f of x in interval notation. Can anybody tell me the concept we're working with there? If you look over here, it's in this box. F of x is this. I would not suggest that you just graph this because the graph is misleading sometimes. What is the concept? When you have a fraction, the denominator can't equal 0, but when you have a radical, what's going on? Almost. It can't be negative. It can be 0. So how do we say what's under the radical, and only what's under the radical, has to be 0 or greater? Okay, we solve that. And then how do we write that in interval notation? Yes, no, maybe, questions? Okay, so what's underneath the radical is the only thing we care about, and it has to be 0 or greater. All right, number 2 says add f and h. Anything we can add together on those, guys? H is this one. What can we add? Yeah, the 4 and the -3 back here, the like terms would be 1. Everybody okay? But otherwise, it doesn't matter what order. We have a 2x squared and we have a negative square root of x plus 1, which you could have totally written in different orders. Can I simplify the plus 1 with the minus 1? Or the plus 1 out here with the 1 under here? No. But the order you wrote them in doesn't matter. All right, g times h. It does say on the quiz you have to simplify that. So if you write down g times h, you'd have to FOIL that all out. Do you want me to take time to do that? Okay, first term times first term would be what? -8x cubed. Outside terms or inside terms, I'm going to do inside next because it's 10x squared, and then the outside is a -16x, and last times last would be a plus 20. Should I factor something out? What have I told you about that? It's not a factoring question. It says simplify your answer. That is simplified. It does not say factor. There's nothing we can combine, so we're done. Please do not factor unless it specifically says factor. Unless it would help you solve, but if it just says simplify, you're done. All right, h minus g. Can anybody look at those and tell me why in the world a pre-calc student would get that question wrong? It says to take h and do what? Subtract g. So what are they going to do? Not distribute, right? If we do distribute, we end up with a 2x squared. Back here we have a minus -4x, which would become plus 4x. And then we had a 4 minus this 5 would be a -1. I certainly could have showed more work, but I was just trying to save space there. Any questions? I think I did it in the right order. No. Yes, I did. Okay. Sorry. I thought I did in the wrong order for a minute, but it does say h minus g, right? Okay, sorry. That was very obnoxious on the video. I apologize. Okay. Do you remember how we did this one? This means put what into what? H into G. But did we need to really come up with the rule when there was a number? Do you remember what we did? We put this number into H So if I put negative 6 into h, I'll have 2 times, oop, there's a mistake waiting to happen, because you got a negative squared. Anybody get that answer? Yeah, I'm getting 76 in my head, okay. Then you take that answer and you put the 76 now into g, right? So now we do g of 76, which would be negative 4 times 76 plus 5. I need help. What? Negative 299? Is that what you said? Okay. Everybody's good? Okay, I hope number 6 is on the next slide because it's cut off on this one. Oh, they all were spread out. What do you know? I'm so good at that. I always think I have to cram everything on the first page. Okay, number 6 says, this is 2 new functions, okay? It's not the same ones we were using. And it says to find this. What does that mean to do again? Put all of f into g. So all of this is going to go down here where there used to be the x. The x gets replaced. So it's 1 over some quantity minus 8. And that quantity is 2x squared minus x plus 5. What can I do with that mess? Do I need to distribute? Is this multiplying down here? No, so what do I need to do? Do you just combine like terms? So I end up with 1 over 2x squared minus x minus 3. Did I get that right, guys? And then the only domain restrictions you have to do are when it specifically asks for them, okay? And this one does. Now this new function has how many domain restrictions probably? Probably 2 because it's a squared down there, right? So this cannot equal 0. We have to figure out what would make it 0. Can you factor that? Let's see, we'd have to have a 2x and a 1x, and the only factors of 3 are 3 and 1. Where do you want to put the 3? Okay, so then I'd have a 3x and a 2x. I'm trying to get a negative 1, so if I had a negative 3 plus 2, I'd get a negative 1. Is that working? Okay, now what? So the 2 domain restrictions are x cannot equal negative 1. And this one, if we did 2x minus 3, we'd get 3 halves. And if it doesn't say interval notation, which this one doesn't, the restriction, okay, doesn't say state the domain, it says give the restrictions, and the restrictions are x cannot equal those 2 things. Brandon, did I lose you? No? Anybody? All right. Number 7, draw a function that is 1-to-1 and explain why and what it means to be 1-to-1. Anybody remember what a 1-to-1 function would look like? 1-to-1 means it passes what? Oh, IP, it's a new word. Because why? What is it? Why do we even care? Inverse will be a function. So how do you want, what do you want me to draw? A diagonal line would work, okay? Anything but a vertical or horizontal line. So oblique, is that the word we use at some point? Diagonal works. You could have drawn a square root graph. You could have drawn half a parabola. Could have drawn a cubic. Anything that will pass both a horizontal and vertical line test. All right, number 8, how do you find the inverse of this? Now, this is a little messy, and I'm going to tell you now, I'm okay with you just kind of leaving it a little messy. Or you don't have to make it messier, maybe that's what I want to say. But what's the idea? You do what? Okay, put y here, and then, okay, I don't know why that negative's way up there. It should be down here. Okay, switch your x and the y. And then we got to solve it for y. Ideas? Subtract 3 to both sides. So I just have an x minus 3. And over here I have a negative and a cubed root of y minus 1. Now what? Yeah, I think we should get rid of the negative 1 before we cube both sides. I'm not sure that it would matter on this particular question, but if I multiply everything by a negative 1 or divide both sides by negative 1, what happens over here? I get a negative 1x and a plus 3, which could also be written 3 minus x if you wanted to write it that way. And now I have left the cubed root of y minus 1. Next, cube both sides. And this is where, if you actually cube that out, it's going to be a nightmare. Because you would have to FOIL out negative x plus 3 times a negative x plus 3, and you get a trinomial, and then you'd have, whoops, multiply by another negative x plus 3. Apparently I can't write on that half of the board over there. So we don't want to do that. I'm just going to let you leave it the way it is. Does that sound like a plan? Okay, so I didn't finish. I'm going to write it here. So I have negative x plus 3 quantity cubed is now y minus 1. So then I'd have what? Negative x plus 3 quantity cubed plus 1 equals y. And I would let you leave it there. In the book, we were supposed to change it to this. But if you don't do that last step, I don't care. You can leave it y equals. There are other ways that could be written, but don't cube it because you're probably going to mess it up. All right, what about 9 or B? This is the one I'm anxious about. I don't know how quickly I could manage to fix this. I never know what I'm supposed to pick that'll fix it. You think that one? I don't know, I feel like I change it to something different every day. It was working, but just not very well. Okay, let's try this. What do we do first? This is a big old y, so then we change it to x equals y minus 5 over 2y plus 3. This is where students start doing some crazy stuff. What is the process I tried to help you figure out? Cross multiply. Which way do you want to write that, since you said it, Xavier? Y minus 5 equals, okay, I'm going to actually write it out. So then we have to distribute that. Okay, what's the next step? And you might have done this already and gotten a different looking answer because you cross multiplied the other direction. That's okay. Now what? Yep, we need to isolate the y's. So I'm going to go ahead and subtract this guy over to this side and add the 5 back over here. So I have y minus 2xy equals, and then over here I have a 3x plus 5. Last two steps, if you've done it right, are to factor out the y and then divide. Okay, how does the y factor out? Everybody get that one? Nobody forgot it? And then to get the y by itself, we would need to divide the 1 minus 2x over to the other side. And I don't know why that's so crammed in there. There we go. Okay, so that's what I got. If you had gone the other direction, you may have ended up with something like this. Did anybody end up with something like that? Same thing. The signs are all different. Okay. Anybody else? Question? I would highly suggest you do the assignment on that, because that is a tricky one that you will not remember all the steps if you don't do it. I do have an extra practice, but I vote we come back to that if we have time, okay? If somebody wants to see another one of those. How do you graph a inverse of a function? The learning target is I can graph a function in its inverse, but I actually give you the function, and then you have to graph the inverse. Anybody know what you do? Yeah, you take a bunch of x's and y's and flip them around. So that point right there would have been 0, negative 5. That's not what you have?
Yeah, we've got a V shape.
Oh, okay. Well, I'm going to just show you what this one would look like, because I kind of think the one on the quiz might look like this. That 0, negative 5 is over here at negative 5, 0. Then we had 1, negative 4, so that would have been negative 4, 1. Then we had 4, negative 3, that would have been negative 3. 4, negative 3, yes. So that would have been, oh, yeah, it's going that way. I was like, negative 3, 4. So it would have been going like that, okay? Because remember, it should be a flip across this line. Okay, yours is a V. Is it down here? It's up here? Okay, and is it going this way? Okay, give me some ordered pairs. What's this point?
That point is 1.
Okay, give me 1 point on this guy. Okay, and then the one over here must be negative 4, 3. Is that enough points to get it going? So if you reverse all those, this one becomes 1, negative 3. This one becomes 3, negative 2. And this one becomes 3, negative 4. Now, mine had no scale whatsoever. It's supposed to look like it flipped across this line, but remember, I didn't use any kind of scale when I drew it, so mine's messy. But I think the size and the shape should have been a little different, but does it look okay on your paper? Got it? Okay. Throw this in your calculator real quick. I don't think you're going to get anything nice. Negative 3 times x to the negative 5th. Is it one of these?
Yeah, it's like
Down here too?
like super close.
Yeah, it is. I don't think the one on the quiz is quite that bad, but
It looks like they both are on 0.
okay.
That's
Yeah. I don't think, I'm not going to grade your sketch. It should just be a sketch, okay? What is the domain and range, though? Now we're doing some graph analysis.
negative.
Nope. Well, think about it, guys. It's -3, and then x to the -5th would mean over x to the 5th. X can't be 0, right? So that's where it comes in. It also has, though, a horizontal asymptote where? At 0 again. So bottom to top is the same thing. Does this have any intercepts? No, it should not. Because you just told me x and y both can't be 0. So there's no intercepts. Is it continuous? I can't draw that without lifting my pencil up, right? I had to pick my pencil up to draw it, so it's not continuous. All right, y is approaching what? Okay, let's start with this. On the left, the y as I go left is getting closer and closer to 0. As I go off to the right forever, this is getting closer and closer to 0. Okay? I know it doesn't look like the values are increasing or decreasing. It looks like they're going straight. But if you were to trace, this is getting the slightest bit more until it suddenly jumps and gets really big. So that entire section is doing what? Increasing from the left until the value of 0. If you go down here, what's happening? It's also increasing, and that is from 0 to infinity. Why can't I just say -infinity to infinity? Because 0 is not, so don't include it. Martin, did you have a question?
It actually touches 0 on y.
Your calculator may round if you go far enough.
Well, no, I mean, like,
No, if you trace over there. You see what I'm saying? It doesn't ever become positive.
so why is this one spaced out?
What?
Oh, there's, like, this one looks
Well,
like
because you
smaller.
could change your window. Try a zoom. Decimal is a good one usually. Yeah, it's just because the values here are very, very tiny. Because you're divided. Look
Well,
how...
no, I meant, like, why does it look like this? Like, where
Okay,
you touch it?
Yeah, because if you put little decimals in, you'll get numbers big or very, okay? But if you put big numbers in out here and you take it to the 5th power and divide -3 by it, it's going to be teeny tiny.
Okay.
But it doesn't ever touch. And I hope there's a better one on the quiz tomorrow, but it doesn't touch. Okay, that's why you shouldn't be just relying on the graph. Okay. Solve and check for extraneous solutions. What do we do first? You don't have these? Oh, okay. Well, here they are. What do we do first? Subtract 5. So I have the 4th root of 128 plus 3x equals 4. Then what would you do? Both sides to the 4th. So you'd have 128 plus 3x equals, anybody know what 4 to the 4th would be? I want to say 256. Okay. Then we'd subtract 128, which is 128, isn't it? And then that's not going to be a nice answer, I don't think. 128 over 3. Okay. You're supposed to check that it works. If you put it back in here, the first thing you do is multiply it by the 3, so then you just have 128, right? 128 plus 128 is 256, and the 4th root of 256 had better be 4, and 4 plus 5 is 9, okay? All right, yeah, it's this kind that you're more often to get extraneous solutions. Okay, we don't want two radicals on the same side, so we want to leave it the way it is. If we square both sides, though, the right-hand side is going to look nice. It's just going to be x minus 45. The left-hand side, I'm going to go ahead and write it out twice. Square root of x minus 3 times square root of x minus 3. Okay, what is square root of x times square root of x? Just x. Then if I have square root of x times negative 3, I get square roots of x. Inside here, we have another one of those. And negative 3 times negative 3 sometimes is 6, but on a better day, it's 9. Okay? I just know the mistakes I see you guys make, and I'm tempted to make the same one some days. All right, guess what? If we subtracted x off both sides, that was gone. Okay? If I combine these, I have a negative 6 square roots of x. Could I maybe subtract the 9 to the other side? What would that be? Negative 54? Did I do that right? Then what? Yes, divide before you square. And now we square it again and we get x. Be careful, you're squaring, not square rooting. 81. Okay. Does it work? The square root of 81 minus 3 would be 9 minus 3 or 6, right? It's not writing where I want it to again. Square root of 81 minus 3 would be 6. Over here we get equals the square root of 81 minus 45. Somebody help me, I don't know what that is. I'm guessing 36. Should be 36, right? I hope. So 6 equals square root of 36. We're good? BN. Okay. Do you have this question? You have nothing here either?
Worksheet 6, 7.
Okay. Well, here's a equation, and you're supposed to tell me the steps.
But not the equation.
Oh, you have this?
Yes, that's what we have.
Okay, but let's back up and talk about the difference between these real quick. And you don't even need to write them down if you don't want to. Okay, if I were to tell you to put a 9 into this, what would you do after you put the 9 in? You'd square root it, then multiply it by 3, then add 4, and then take the opposite of it. So that's the order you have to tell me the transformations in. Okay, so this is the parent function. The first thing after you square rooted it was you multiplied by the 3. So the first thing you would tell me is it is a vertical stretch, and vertical things always do exactly what they seem. So that's a stretch by 3. Then this plus 4 before you worry about that out there. Yep. So then it's a vertical shift up 4. And then it would be, the last thing would be that reflection over what's on the whole thing. Yes. So it flips this way, up and down. The difference is on this one, if I told you 9, you would square root and then multiply by 3 and the negative, right? So this one would have had a vertical stretch and a reflection over x. And it honestly wouldn't matter which of those you did first, but you can't do this until both of those are done, which is shift up 4. These two could be interchangeable. Do you need me to go through that again or not? Yes? The order? Okay, this one would be first this, which is what? Left 5. Then this, which is reflect over y. Is everybody good? Because it's changing x values inside here. And then last would be up 10. This one, if I put a number in here, the first thing I have to do is what? Yeah, reflect over y. And then a plus 5 inside actually moves still left. Oh my gosh. Yeah, pretend I can write left. I don't know what that says. And then up 10. Okay. You have this. So tell me how to write this on any function. A vertical compression of 1/2 would be 1/2 f of x. Down 5. Minus 5 on the back because it's up and down. Okay. Reflection over the x-axis, which is upside down. But how do I make that happen in this order? Yeah, I have to say the last thing I'm going to do is reflect it. Okay, this one says reflect across the y-axis, which is changing x values, so it goes where? Inside. Then it says right for. Some of you would want to do an extra parenthesis. And then right for would be minus 4. You actually don't need the extra parenthesis in there, but it would be fine if you did that. Right 4 is minus 4 and then up 7. All right, questions? All right, write a new equation for a transformed, oh, we were so generous. We didn't even do anything, Harry, it's just a quadratic. So it's y equals x squared is the parent. Okay, what does this mean has happened to it? Left 2 and down 6, how do you write that? Okay. But it also goes through this point, so there's some kind of stretching or reflecting or both going on. So there's an unknown stretch out here. Where am I going to put these two? These were h and k if you were thinking of vertex form. These are an x and a y. So we got to put the 24 in over here. Okay, what do we have to remember? That's all multiplied, so what do we got to do first? Add the 6 over to the other side and get 32 equals a times 10 squared. Yep, thank you. So that would be 100 that we need to divide over here. So the stretch would be 3/10, and we would have to write it back in here. Okay, if you do slope between those 2 points, I feel like giving you a 1 on the whole section. Parabolas don't have a slope. If all you had to do was find the slope, wouldn't I be doing and teaching it that way? Okay, just saying. See people doing the slope on a parabola. All right, you don't have this. This is a worksheet that's over in the bin if you want practice on matching. I can go through these if you want. Otherwise, you can take the worksheet. How about if we switch to the other worksheet, though, because it does have some matching. Can we do that instead? If we go to the back of the other worksheet, number somewhere here. Okay, 15? Yes. Yes. Okay, so this is the parent up here. These are all the options. What happened? I wanted to say it was just upside down, but I don't think that's true. Because if I switch that point upside down, it would be down here. Okay, it would look like this. So it's also been shifted up. So what's upside down and up? Some kind of adding on the back. So F. All right. The next one I have is this one. What's happening here? This was at -2 and +2, and now it's a +1 and 5, so it went 3 right. Okay, this is upside down, but normally upside down would have just done this. So this point that was at like, I don't know, 18 or something is now down here. Well, the only other one that's upside down is D, and that's a stretch by 2. So if that was at like 18, is it at like 36 now maybe? Okay. Okay. So we'll go with D. I didn't give you choices like 2f of x or 2.2 f of x. You know, they're not that close. All right. I think Hofbauer sat on this. It used to go up to like 18, but now these values didn't change, but this is only going up to like maybe 6 or something. Yeah, the only one that's a vertical shrink is E. Okay, this is the, nope, this is not the trick one. I think it just went up. Do you think it just went up? The only one that's only up is A. Someone could shut that door. Guys, this nothing changed. How could it possibly have nothing change? Yes. If you reflect this way, is it going to look any different? And isn't that what that means? Reflect over Y? Okay, that was a trick. All right, what else? We have 5 minutes. I can do some more of this. We could do this. We could do another graph analysis of an icky one. Yes. On this worksheet? Okay. Some more of this fun. Write a rule for the function whose graph is obtained from the given parent function. So the parent is x cubed. If we shift it left first, 3 units to the left, how do we shift left 3? X plus 3, and it's inside on the cube, inside of the cube, okay? And then reflect over the x-axis means it's upside down, so that would be the negative out there. Number 11 says to take this and describe the transformations. Okay, guys, this was the parent. What would you do first? Describe what the 3 does, right? And a 3 inside. Horizontal, and because it's the opposite of what it seems when it's inside, yeah, shrink is fine with me. The book, I think, would use the word compression. Now, you could either say by 3 or 1/3. I really don't care. It got smaller. As long as you use the word compression, I'm good. You would divide all the values by 3. So, okay, and then the last thing is, what does this do? That's a vertical shift down 4. Okay, what else do you want me to do? Ooh, can I do this one? Number 12, if I had you write F over G, you would literally just write the F over the G. But that's the only one that's got a domain restriction. What can I not put in there? 2x minus 3 equals 0. X equals 3 halves. So x cannot equal 3 halves, right? Which it doesn't say we have to do it in intervals, so I'm not going to. What else? What about the domain of number F of this one, number 4? How do you do that again when you have a radical? Whatever garbage is under the radical has to be or equal to 3. Oops, 0. Oh my gosh. Magically 3 has some properties. So 5x is greater than or equal to 3x is greater than or equal to 3/5. So you would write 3/5 to infinity. Domain of h of x can't be what? 7. If you had to do interval notation, it would look like that. What about putting h in g into h? You'd have 2 times x cubed minus 1 plus 9, and you'd simplify the top. And then down here, you'd have an x cubed minus 1 minus 7. So you'd just get 2x cubed minus plus 7. Minus 2 plus 9 would be plus 7, right? And an x cubed minus 8, and nothing cancels. Okay. I don't probably have time to do this, but I would kind of like to talk about this one. Can anybody type that real fast? Be negative 4 over x squared. So I think it's this. Does that look right? Yes? Okay, what is the range of that? Everything's working until you get up to what? 0. So it's negative infinity and it does not include 0. There's nothing above 0. The intercepts are none, even though mine looks bad. It's not continuous. Both ends are approaching what? Nope. If you go off to the left or off to the right, both times you're just getting closer and closer to. Okay. Oh yeah, 1 should be positive, thank you. What is it doing over here? Decreasing from negative infinity till 0, because it's coming from the left. These are x intervals, remember? And this side is increasing, so from 0 to infinity it is increasing. All right, I will tell you this. If you're concerned, Abruzzo did those two things in the opposite order. Okay, so she went through almost all of this worksheet in her video. Do you know what I'm saying? So if you're worried about the fact that I skipped a lot of this and did the review, she did it in the opposite order, so her video would cover more of this worksheet. But the keys are both in Google Classroom, okay? The keys to everything.